Hi everyone, myself Benny John, Assistant Professor, Mechanical Engineering. Today we are going to see about theory of machines, that Unit 2, gear and gear trains. In this chapter, that we are going to see that gear trains. Define gear trains. That is, two or more gears are made to mesh with each other for transmitting the power from one shaft to another. It is depends upon the velocity ratio uh, and position of shafts. Next, types of gear trains. There are four types: the simple gear train, compound gear train, reverted gear train, and epicyclic gear train. The first three types the gear trains are the shafts which mounted with fixed to each other, and last epicyclic, the axis of shaft which is mounted only to move relative with fixed axis. There is only one gear can each shaft, that's known as simple gear train. By the gear represents the pitch circle when the distance of two shafts is small. The two gears one and two are made with each other to mesh for transmitting the motion from one shaft to another. That's shown in the figure 1. And gear 1 is driver and gear 2 is driven or follower. They may notice that motion of driven gear is opposite and move to the motion of driving gear. That's the speed ratio and train value. The speed ratio is the ratio of n1 by n2 equal to t2 by t1, and train value is the ratio of speed of driven or follower to the speed of driver. That's the train value equal to n2 by n1 equal to t1 by t2, where n1 and n2 equal to speed of gear 1 and gear 2. T1 and T2 is the number of teeth on gear 1 and gear. Next one, compound gear train. The two or more than one gear on shaft is known as compound gear. It is an ideal gear for simple train, does not affect the speed ratio, and intermediate shafts has two gears rigidly fixed. They may have same speed. That's the speed ratio. The ratio between the speed of first driver to the speed of last driven or follower. And train value, the ratio of speed of last driven or follower to speed of first driver. And reverted gear train. This is the axis of first gear and the last gears are coaxial. Then it is known as reverted gear. We can see in the figures the gear 1 and gear 2 in the opposite direction, since 2 and 3 are mounted on the same shaft. Therefore, the form of compound gear and gear 3 will rotate the same direction of gear 2. And gear 3, the driver drives the gear 4 in the same direction. Next, design of spur gears. First, we consider about the let us consider the distance between the center of shaft n equal to number of speed of driver and t1 equal to number of d1 equal to pitch circle diameter n2 t2 t2 corresponding of driver or follower, while the distance x1 equal to d1 plus d2 by 2, the velocity or speed ratio is n1 by n2 equal to d2 by d1 equal to t1 t2. And the epicyclic gear, if the gear A is fixed, the arms are rotated axis of gear A, then the gear B is forced to rotate upon and around gear A. Such as the motion is known as epicyclic gear. Therefore, the gear trains arranged such as manner that one or more members of move another member. That is known as epicyclic gear trains. It is also known as symbol or compound. There's a velocity for the epicyclic gear train. There's a traveler form. This is TA equal to number of teeth on gear A, TB equal to number of gear on gear B. The calculations are made as the condition follows. First step, the dam fixed gear A rotates it through the plus one revolution. The revolutions are shown that MC, gear A and gear B. While the amp is fixed for gear A rotates x plus. There is 0 plus x and gear B minus x into TA by TB. Add that one. Add x plus y. Revolution of all elements. This arm is plus y and gear A is plus y and gear B is plus y. That's the further revolution of the element. And total motions for the next one. Let's say arm A x plus y and arm C plus y. Y. The gear B is y minus x into TA by TB. That's all. Thank you.